Oh, it's blue. We are starting 12.3, which is, or actually logarithmic function. So 12.3 is logarithmic function, and 12.4 is properties of log. So 12.3 is short. We will probably not finish 12.4, so we'll see how far we go today. Let's start. Are you guys ready? Yeah, we're doing 12.3 and 12.4 today. So 12.3 is logarithmic function. All right. Okay. So what is a log function? So basically, log is the inverse of exponent. Well, so basically, okay. Now, before we have y equals to 2 to the x. Has inverse. So, do you guys remember how we find inverse? Yeah, how? Is each the x and y? Yes, that gives us the inverse. So x is equal to 2 to the y. 2 raised to the y. That's right. Now, if I ask you, what is this? So y is equal to what? So I want you to write it specifically, y is equal to what? So x is 2 to the y. This is where the log notation is introduced. This is log base 2 of x. Yeah. So basically, x equals to 2 to the y is equivalent to log base 2 of x. Okay. So what we notice here is the base of the exponent is equal to the base of the log. So x equals to 2 to the y is equivalent to y equals log base 2 of x. Miguel? Your notebook. Okay, just close it there. And then put on it there. Yeah. Okay, then put it there. Okay, but close it. Now, anyway, what does this actually mean? So we're graphing later on. Yeah, you can turn it on. So suppose I'm asking you, well, what we could do, let me do this first. We could rewrite all exponential equations as log equations. So they are equivalent. Yeah. So, for example, or let me write first. Y equals to log base a of x. This is equivalent to x is equal to a to the y. So what we notice here is the base of the log is equal to the base of the exponent. Okay, so log is actually inverse of an exponential function. Now, let's rewrite some. So convert to exponential notation, and then we convert to log notation, and then we could graph. So convert or rewrite to an exponential notation. All right. So convert to an exponential notation. So number one, c is equal to log base 3 of 81. So this is Chris's question, isn't it? So what does this mean? What is log base 3 of 81? How do I convert these to exponential notation? Good. So the easiest way to do it, and I always do this because this is always confusing. Now, the base of the log, we write it below. So it's not log 3 like this. Log base 3 and log 3, this is different. Later on, you'll see this is log base 10. Yeah, so when we say log base 3, we have to write the base below as a subscript. Okay. Now, let's see here. What is the base of the log? 3, so it becomes the base of your exponent. Yeah. Now, this is how I always remember. 81, before it was crowded with the other people, with the other logs and 3 and the base, so now it's alone. So this is 81 by itself. Before T was alone, so now it's in the crowded place, 3 to the T. So 81 is 3 to the T. Can we solve for T? Yeah, so 81 is 3 to the what? 3 to the 4 is 3 to the P. Yes. So what is P equals to? 4. Yes. So log base 3 of 81 is 4. So that's one way. Okay. So there's another way to find what is log base 3 of 81. What is log base 10 of 0.1, for example? We will do it later on. So I will let you know a different meaning in a little bit. So what about if I have log base 10 of 0.25 is equal to x? How do I write this? Using exponent. Yes, the base will be 10. What is the exponent? The x is equal to 0.25. Yes, we can't really solve these, right? So we're just rewriting before we can solve. So we continue. What about if I have log base b of a is equal to c? No, I think for this you have to, when you rewrite, you just have to choose. You're talking about number 2? You're going to when it asks you to rewrite, then this is how you're going to rewrite. No, this is not solving. You can't solve. Yeah. Now, how about number 3? Can you solve? Not either. But let's rewrite it as using exponential notation. What's the base? B. What's the exponent? C is equal to A. Yeah. Yeah, you're just rewriting. You're not solving. Yeah. Okay. Now, let's see. What does actually log mean? So let's do a conversion, another conversion, and then you'll see. Yeah. So another example. So this is one example. So another example is convert to log notation. So rewrite using log. So suppose number 1. 4 to the negative 5 is equal to 1 over 1024. So how do I write these using log? Number 2, 10 raised to the 0.4771 is equal to 3. Number 3, e to the negative 2 is equal to 0.1353. Okay. So how do I write these into logs? So that's easy, right? Log. What is the base? What is the base of the log? No. 4. Yes. So the base of the log and the base of the exponent are the same. So log base 4 of, yes. This is negative 5 together, so now it has to be log. So this one has to be 1 over 1024. Yeah. So log base 4. So let me write it a little better. So log base 4 of 1 over 1024 is equal to negative 5. Then done. You're not trying to solve anything, you're just trying to rewrite. How am I going to rewrite these? Log base 10 of 3 is equal to 0.4771. Yes. All right. Last one. Log base E of 0.1353 is equal to negative 2. Yeah. So you're just rewriting back and forth. Exponential to log, log to exponential. Yeah. So far it has no meaning, right? Well, what does it mean? No. Let's talk about what E is. Yeah. E is a natural number, so let's do it on the next page when you're done. Finish? Okay. So E is a natural number. It's called the natural number. So the natural number. Okay. And the value is approximately 2.7. But your calculator has it. So this is an irrational number. So it goes on forever. This is irrational number. All right. So this is irrational number. It will go on forever. Yeah. This is like pi. Pi is approximately 3.14. E is approximately 2.718. Yeah. What is this actually? E is actually 1 plus 1 over n raised to the n when n is large. So the definition of E is actually 1 plus 1 over n raised to the n when n is very large. So the larger the number you pick for n, the closer the value of it to E. So what is the larger number you think of? No, I mean, I'm talking about 10,000, a million. Yeah, so the closer it is to the infinity, the closer the value is to E. So E is an irrational number. Yeah, and it has something to do with the exponent. Later on when you take calculus, anyone going to take calculus? Yeah, there is a derivative of ln x is itself. Yeah, okay, it doesn't matter now. But anyway, E is the natural number and the value is approximately 2.718. When you think about E, think about pi. What is pi? No, that's the approximation for pi. Yeah, pi is the ratio between circumference and the diameter of a circle, right? P over D. Yeah. But E is, the approximation is 2.718. Your calculator should have an E. Yeah. Yes, it will have an E. Now, let's go back to what log means. So suppose I ask you, what is log base 2 of E? So I want you to fill this out. Yeah. Or what is, for example, log base 3 of 1 over 27? Or what is log base 5 of 1 over 125, for example? That's what I want to know. Now, this is exactly the same question as when I'm asking, so this is my question. 2 raised to what number is equal to 8? So basically, I'm asking you 2 raised to what number will give me 8. So 2 raised to what? Give me 8. Raised to the third power? Yes. So the answer is log base of 8 is 3. So if I ask you what is log base of 8, that's the same question as 2 raised to what number will give me 8. Alright. Okay, so now, how about this? Log base 3 of 1 over 27. What's the value? Well, this is the same thing as asking 3 raised to what number? What number will give me 1 over 27? Or if I write it short, 3 raised to what number will give me 1 over 27? Negative 3? So what is my answer to my log question? Negative 3. Does that make sense? Can you do the third one? What's the answer to the third one? 5 raised to what number? Will give me 1 over 125. Well, what is the answer? Negative 3. 5 raised to the what number will give me 1 over 125. And the answer is negative 3. So, you know how to answer your question. What is log base 3 of 81 is what? Yes. Log base 3 of 81. So what question am I asking? 3 raised to what number will give me 81? And the answer is 4. Yes. Make sense? Okay. So on your homework 12.2 and 12.3 are together. Starting what number is it was? Is it number 5? Number 23? Oh, okay. So part of it is 12.2 and part of it is 12.3. Okay. Alright. Yes? Okay, so we know what log means. Now we're going to graph. Yeah. Alright. If I ask you, what is log base 10 of 0.001? What would my answer be? What is 0.001 basically? Log base 10 of 1 over 1,000, right? So what is it? Negative 3. Yeah. Doable? Okay. So now we're graphing. So B, graphing log function. Alright, so I want to graph y equals to log base 2 of x. Alright. Now there are two ways. We could just substitute in the value. Or we could rewrite this as exponent and then graph the one from the exponent version. So let's do that. So two methods. How do I rewrite this using exponent? What is the base? 2. So it becomes the base of the exponent. What is the exponent here? Y or x? Y. So before y was alone, so now it's in a crowded place. So it has to be the exponent. How about this x? Before crowded, now it is alone. So that's how I always remember how do you switch from log to exponent and vice versa. Because usually it's confusing. Oh, I use circular method, blah, blah, blah. It moves here and it moves here. Anyway, it's confusing. Yeah. So it's better to think, oh, before it was crowded, now X is alone. Before Y was alone, so now it's in a crowded place. So before alone, now crowded. Yeah. So now we're going to graph X equals to 2 to the Y. So I am going to choose Y, and then I'm going to solve for X. X is 2 to the Y. What Y values can I choose? Anything? Yes. So -2, -1, 0, 1, 2. Okay. All right. So 2 to the -2. You gotta put your phone here. No, I'm not picking on you. If I see anyone using phone, no, I'm not. If I see anybody using phone, I ask them to put it on my desk. Everybody. Yeah. But I've seen you a few times. So this is, what is 2 to the -2? 1, 4. 2 to the -1. 2 to the 0. 1. 2 to the first power. 2. It's just that sometimes when you put it 2, but he's behind you, so I don't see it. But I know you guys are 2. No, I'm not. No, definitely not. No, everybody, if I see them use the phone, then I'll ask them to put it on. Am I right? Yeah, it's just you're in front of me, so I always see you, right? Yeah. You're just scrolling and looking at it. Yeah. Just scrolling. I saw you scrolling. Anyway, so let's graph it. Yeah. Just put your phone in next time, okay? All right. So let's see here. X, Y. So 1, 2. Oh yeah, I'm doing it to everybody, okay? Not just Miguel. Let's see here. Okay, so -2, 1, 4. Or actually, look at these. I made a mistake. Supposed to be what? Which one's X, which one's Y? So be careful here. I almost made a mistake. Which one's X, which one's Y? Yes, so it's better if we write it. So this is 1, 4, -2, and then half, -1, 1, 0, 2, 1, 4, 2. Yes. 1, 4, -2, so it's right here. Half, -1 is right here. 1, 0, 1, 2, 4, 1, 0, 2, 1. That's what I mean. So not this one. And then 4, 2. Alright, so my graph looks like this. Okay. This is Y is equal to log base 2 of X, which is equivalent to X equals to 2 to Y. Yeah, it's exactly the same. X equals to 2 to Y is equivalent to Y equals to log base 2 of X. Yes, they are exactly equivalent. Yeah. Now, can I ask you what the domain and range is? So Y is equal to log base A of X. Y. Okay. Now, can you tell me what is the domain? What is the range? What's the domain? From what? From 0 to positive infinity. Yeah. Good. So it never crosses the y-axis, so that's why I'm not using a bracket here. I'm using parentheses. Yeah. How about the range? Negative infinity to positive infinity. Yeah. Yeah, it keeps going. No, but it's not going to cross. It's going to be closer and closer and closer to the y-axis. It's not going to close it. So we call this what type of asymptote? Vertical asymptote. So before we had a horizontal asymptote, right? Okay, this is a vertical asymptote, which is the y-axis. What is the equation of the y-axis? The equation of the y-axis is x is equal to 0. Yes. So the equation of the y-axis is x equals to 0. Yes? Okay. And this is true for all log functions. So can we shift the log now? Let's shift the log. Yeah. Okay. So we have to remember at least this point on our log function, because we're going to shift the log. If you don't have a shifting of log, you need that. Asymptote, yes. It means when it gets big or when it's going to get closer and closer to a line. Yeah. It behaves like the line. Let me see here. Let's see here. Now, can we graph the inverse? How do I graph the inverse of these functions? Let's graph it here. How do we graph inverse last time? Right. So let's switch this. So we're going to graph the inverse. Yeah. So 1/4 comma -2. So it becomes -2 comma 1/4. So it's right here. And then -1 comma half. And 1 comma 0 becomes 0 comma 1. 2 comma 1 becomes 1 comma 2. And then 4 comma 2 becomes 2 comma 4. 2 comma 4 is right here. So this is the inverse. All right. So do you know what is the inverse? What is the equation of the inverse here? What did we do to find inverse? So we switch the x and y coordinates. So 1 comma 0 becomes 0 comma 1. 2 comma 1 becomes 1 comma 2. Right? And then 4 comma 2 becomes 2 comma 4. So this is the inverse. What is the equation of the inverse? Y is equal to 2 to the x. Yes, so y is equal to 2 to the x. This is the inverse of x is equal to 2 to the y. Yeah. I mean, 2 squared. So this is y is equal to 2 to the x. Okay? And this y equals 2 to the x, which is this graph. Okay, this graph, this is y equals to 2 to the x. This is the inverse of x equals to 2 to the y. Okay? Okay. Good. Actually, we don't have to graph the other thing. Okay? Now, what we want to do next, let me see. Solving log equations, solving simple log equations. Yeah. So we're going to solve simple log equations. Are you guys ready? Yes. So let's see. Solving simple. So in this case, later on we solve more difficult ones. Log equation. All right. So number one, log base 4 of x is equal to 3. And then number two, log base 2 of 16 is equal to x. Number three, log base x of 8 is equal to 1. So how do you think you'll solve these? Well, we will write it as exponent, right? Okay. So why don't you write it as exponent and then solve it? So how do I write the first one as exponent? So start with the base. What is the base here? What's the base of the exponent? 4 raised to 4 raised to what? No. 3. So don't get mixed up with that. Yeah. Don't get mixed up. Before x was crowded, so now are you going to put, if you're going to put here again, then it will be crowded again. So x has to be by itself, right? So where will x be? Yeah, to the left. So x is equal to 4 here. Yeah. So the exponent is 3. What is 4 cubed? 64. 4 times 4 times 4 is 64. Finish. Right? Okay. So now, number 2, log base 2 of 16 is x. So what would you do to solve for x? Yes, so 2 to the power x is equal to 16. Okay. No, we have to solve for x. So 16, can I write 16 as base 2? What is that? Oh, okay. Can you put it to silence? Okay, then put it on my desk. If I don't ask you to put it on my desk, then Miguel's going to say, oh, you're picking on me. So put it on my desk. Okay. That's very funny, right? It's hilarious. Actually. Okay, so anyway, can we write 16 with base 2? Yeah, it is 2 to the what? 2 to the 4? Okay. 2 to the 4 is equal to 2 to the 6. So what happens to x and 4 here? Yeah, x is equal to 4. Alright. But actually, you can do it this way also, right? Log base 2 of 16 is, do we know what log base 2 of 16? I mean, we just did it. What is log base 2 of 16? 4. So, and then you can just say directly x equals 4, because we know log base 2 of 16 is 4. So there are two ways to do it. We could rewrite it as exponent, like what we did here, or we know what log base 2 of 16 is, don't we? Yes, which is 4, so that's what we do. We just write 4. Yeah, instead of doing all these work. It's up to you. There are two ways to do it. Yes. X to the power of 1 is X. X to the power of 0 is 1. Yeah. Now, number 3. How do I rewrite this? So, X to the power of 1 is 8. So, what is X to the power of 1? Yeah, X is 8. Yes. Then we are done. Yeah. So, do you guys remember what is A raised to the 0? 1. So any number raised to the 0 is 1, except 0 raised to the 0 is undefined. But any other number raised to the 0 is 1. Yes? Okay, good. I'm done with 12.3, so it's short, isn't it? Yeah. So I just want to mention something which you will use later. Remember the graph of the log looks like this? Yes? Remember? So what is the domain? It's positive number. So we have y equals to log base a of x. So this part right here that comes after the log, this is called the argument of log. So the name, this is called the argument of log. Yeah. And it must be positive. So the argument of log must be positive. You see, it's not defined for negative number. So whatever comes after log here must be positive. Yes? Okay, so something that you need to remember. Now, let's talk about the properties of log functions. So I am done with 12.3. What did we do in 12.3, by the way? We calculate some log values, like log base 2 of 64, log base 2 of 16. We grab the log function. What else? We rewrite log as exponent and vice versa. So you remember all those? Okay. Good. So now let's move on to 12.4. I'm going to say this first. All right, save. Okay, and then let's close this. Let's close this first. So we're done with 12.3. We're starting 12.4. So 12.4 is properties of log functions. Yes. So let's share the desktop again. Okay, this is 12.3, so let's do a new note. This is 12.4. Properties of log functions. Properties of log functions. So now, this is product rule. So we're talking about product rule for log. Okay. Log base A of mn. So this is product. Yeah. This is the sum of, equals the sum of 2 logs. So this is log base A of m plus log base plus log base A of n. Alright. Okay. Let me see how many. Yes. Yeah. Do you want to know why? Why? So why? Okay. So class log base A of n is equal to x. and log base A of n is equal to 1. All right. So we will let log base A of n is equal to x and log base A of n equal to y. Now, can we convert this into exponents? How do we convert this into exponents? Each of them. So converting to exponents, what will this be? A raised to the x is equal to m. Or you could say m is equal to a to the x. That's right. Okay, how about this? A to the y is equal to m. So if we convert, then this is what we have, right? Okay, so then we will multiply. What is m times n? A to the x multiplied by a to the y. Is that right? Okay. So what is a to the x? What is a to the x times a to the y? A raised to the x plus 4. Okay, good. So now how do you prove it? So look at this. Log base A of mn, right, is equal to log base A of a to the x plus y. What is log base A of a to the x plus y? So can you follow me? From here to here, you can follow from this line to this line. Can you guys follow? Okay. And then, so those are fine. So mn. So remember, your m is a to the x, right? Your n is a to the y, correct? Okay. So m times n is a to the x times a to the y. What is a to the x times a to the y? A to the x plus y. That's right. Yes. So from here to here, you guys are okay? Okay. Good. Now I'm going back to my original because this is what I want to prove. Right? Log base A of mn, well, mn is, I already wrote down what mn is. Mn is a to the x plus y. So if I'm copying this and then I'm substituting mn as a to the x plus y because we said that they're equal. Isn't it? What is log base A of a to the x plus y? So if I ask you, what is log base 5 of 5 squared? So what question am I asking? 5 raised to what number is 5 squared? So what's the number? 5 raised to what number will give you 5 squared? Come on, this is easy. 2, yes. So isn't it? Yeah, so 2. So my question is, 5 raised to what number will give me 5 squared? Well, of course, my answer is 2. Okay. So, for example, what log base 4 of 4 squared? What is log base 4 of 4 squared? So 4 raised to what number will give me 4 squared? Isn't it? So what is my answer? 2. Yes. Now my question is, this, I want to know log base A of A raised to the X plus Y. So what am I asking? A raised to the what number is equal to A raised to the X plus Y? What is it? X plus Y. Yes. So this is equal to X plus Y. So A raised to what number is equal to X plus Y? So my answer is X plus Y. So that's it. You're done, right? So log base A of Mn is equal to, what is your X? Your X is, this is your X here in the beginning. What is your X? Log base A of M. What is your Y? Log base A of Y. So this is the proof. Yeah, that's right. So proof is always long, right? Okay. What happens if the proof is confusing? Don't worry about it, but remember the property. But each of the property that we will write down can be proved. Yeah, so it doesn't come from heaven. Oh, log base A of Mn is equal to log base A of M plus log base A of M. No. So we do have the proof. It's just the proof is a loaded blank string. So what happens if you don't want to know the proof? That's fine. Remember the property. Yeah. So will you remember the property? I'm not asking you to remember the proof. I'm just asking you to remember the property, the product rule. Yes? Okay. So now, the next question is, let me know. Did I put my notes somewhere? Oh, here. Yes. So, for example, express as sum of love. So, number one. Yes. Log base 5 of 25 times 125. So simplify if possible. And then number two, log base C of AB. All right. So number one, what should we do? So this is product, so we will write it as log base 5 of, log base 5 of what? 25, and then what sign? Plus log base 5 of 125. That's right. You can. So you have a big number. 25 times 125, what is that? 2,000, 2125? Yes, you can. You can multiply. You're right. But then we want to simplify if possible. Yeah. So if you have log base 5 of 2,025, 2125 or 2025? Or 3125? Yes. So log base 5 of 3125. What is log base 5 of 3125? So same thing, it will be equal to 5. Right? Now, what is log base 5 of 25? What's log base 5 of 25? 2. What is log base 5 of 125? 3. So 2 plus 3 is 5. Yes. So same thing, if you multiply, but the question is asking as expressed as sum of logs. That's why. Yeah, that's why we separate them. Of course, you can multiply. What did I do with this part? So we evaluate log base 5 of 25. Yes, because we can. Now, how about number 2? What should we do? log base C of A plus log base C of B. Yes. You're right. All right. Good. Yes. So now, let's do another example. Yes. You can't do anything here. You can't evaluate any values from here, so we're done. The next one is expressed as a single term. So I'm sorry, I have to write here. So below here. So expressed as a single term. Okay. Log base A of 7 plus log base A of 12. So what will this be? Can you express it as a single term? Log base A of 7 multiplied by 12, which is 84. So this is log base A. 84. That's it. There's nothing else you could do. This is base A. Yes. So you only have one log. Here you have two different logs. You have this log and this log. Yes. So here it says express a single term. You have two log terms. You want to change it to only one. Here it says express the sum of logs. You have product, so it's the sum. Yeah. Okay. So for example, product rule. So let's do quotient rule. Yeah, this is the answer. Log base A of 84. This is 8, yes. Is this too small or too big? Yeah, I know. Yeah, this is A. Whenever I write base or exponent, it's always small. Yes? Okay. So let's continue. Now, quotient rule. So, quotient rule. So, can you guess what will this be? Log base A of m over n. What do you think this will be? This is division, quotient. What will this be? Yes, you are right. So this is log base A of n minus log base A of n. And the proof is almost the same as product rule. So we're not going to go over the proof, right? You're just going to remember the proof. Okay. No, you mean why we choose m and n instead of x and y? No. Yeah. So it's just a variable that we choose. Yeah. So for example, express as difference of logs. Okay. Number 1. Log base to 53 over 17. And then number 2, log base 6 of A over B. So that's easy. What is it? No. No. Log base 2 of 53 minus log base 2 of 17. Oh, by the way, let me call this AX BY. Okay. So instead of A over B, I'm going to write AX on top and BY on the bottom. So what will this be? log base 6 of A. Actually, we can separate this also, right? This is multiplication, isn't it? Yeah, so plus log base 6 of x. Okay? And then I'm not done here. Can I just write it down here? It's not confusing, right? Hopefully I continue. But I need to use the space later. So I'm not done. So minus log base 6 of b. And look at these. Where is the y? Below. So it's also minus log base 6 of y. Yeah. So the y and the b are both below. That's why we use minus and minus here. And the a and the x is on top, so both are 1. Yes? Okay. We don't know what log base of 53 is and log base of 17. You cannot simplify, right? Which one? Yeah, you do. Yeah. This one we cannot calculate yet the value, log base of 53. If this were, for example, log base of 8 minus log base 3 of 27, then we know how to calculate things, right? What is log base of 8? What is log base of 8? What question am I asking if I want to know log base of 8? 2 raised to what number will give me 8? Yes. What is log base of 27? 3 raised to what number will give me 27? 3. So this is 0. Now, something like this we can evaluate. So we evaluate. Something like this, can you evaluate? No. So we leave it the way it is. You see it? So this is a different story if I have log base of 8 and this is log base of 16, for example. Then we will evaluate. But now we don't because we cannot evaluate. Yeah? Because so if we cannot evaluate, we leave it the way it is. Yeah? But sometimes you can evaluate, so we evaluate. Yeah. For number 2, this is the answer. There's nothing we can do. Yeah? Now, how about if we express as a single log? So express as a single log. All right. So number 1, log base A of 5. I'm going to put in some pluses and some minuses. Okay? Plus log base A of 6 minus log base A of 7 minus log base A of x. So they're all log with the same base. What is the base? What's the base of the log? A. Yes. So log with base A. So what should you put on top? 5. What about the 6? 5, 6. Multiply, not x. And then what happens to 7 and x? Divided by 7x. So can I simplify 5 times 2? Yeah, so we go ahead and do it. Log base A of 30 divided by 7x. That's it. Can't do anything else. Yeah. So for 7? Okay. Again, we can prove this almost the same way as the other one. Because I asked you, this is 7. This is the question, the problem. This is the question. So express as a single log. 7x. Yes. So number 3, it's called power rule. Alright, power rule. So log base A of m raised to the power. So this is the most powerful thing with log, is that you could bring down the power. So this is equal to C multiplied by log base A of m. Alright, so this is called power rule. So, for example, log base B of 10 squared. So here this is a little confusing because you have a base, which is a subscript, and you have a 2, which is an exponent. This is a power. So superscript, so you both have a subscript and a superscript. So what can we do to the power? Bring it down. So this is 2 times log base B of 10. So basically you can bring down the power. So what about if I have log base A of cube root of 5? How do I rewrite cube root of 5 as a power? 1/3? Yes. So log base, base A, sorry. Log base A of 5 raised to the 1/3. So 1/3 is the exponent for 5. And what can we do? We could bring it down. So 1/3 log base A of 5. So you could bring down the power. Yeah. All right. Okay. Now, we also have cancellation properties. Oh, maybe I should put this. This one looks like a. Now, the next property is cancellation property. This is the one that we already know. Log base B, I usually use A, so let me use A. Log base A of A to the K. So there's no need for it. Cancellation property, should I write that down? Yeah, maybe let me write that down. So cancellation property of log. Yes. Henry, you have a question? No? Okay. Do you want to move? All right. So the first one is log base A of A to the K. Well, this one you know, right? What question are we asking? No, what question are we asking here? A raised to the what, right, is equal to a K, A raised to the K. Yeah, this is called cancellation property. Why? Because it cancels the log. You don't have a log anymore. Okay. Log base A of A to the K, that's just equal to K. Okay. The other cancellation property, so there are 2. The other one we need to prove it. A raised to the log base A of K. This is also equal to K. So we have 2 cancellations property of log. Yeah. So log base A of A to the K is K. A raised to the log base A of K is also equal to K. This one is to be proved, but we're not going to talk about the proofs. It might be confusing. So we're just going to stay. Right? Now, the other properties are, what about it follows from the cancellation property? What is log base B of B? There's no name. No. Log base B of B. It follows from the cancellation property. What will it be? 1. Why? Well, because this is log base B of B to the first power. Remember? B is the same as B to the first power. So this will be 1. What is log base B of 1? This is log base B of B to the 0. So this is equal to 0. No. This is how you get 1. 1 is B to the 0, right? Yes. So you're canceling the logs. You're left with 0. Here you're canceling the logs. You're left with 1. Yeah. Okay. So I'm not done with 11.4. Are we supposed to be done now? Should I do examples on this? 11:40. So you want to be done? Yeah. Okay. So now this is a little bit new. How come product becomes sum and quotient becomes subtraction? So I suggest you start the homework as soon as possible. This is new, yeah. So what numbers do you tomorrow night? 12.2 and 12.3 are together, right? Okay, so it's 12.1 and the other numbers will be 12.2 and 12.3. Yes? It will give you tomorrow night, Wednesday night. So this is 12.4. We will continue with 12.4 tomorrow. Yes? Okay. Okay, guys. Let's see. So we will continue with this tomorrow.